trigonometric ratios. There are three main trigonometric ratios, and they all have to do with a right triangle. So in our right triangle here, we have capital letters A, B, and C, which are marking our angles. C is generally going to be our right angle, and then the opposite, or the sides, we have lowercase a, lowercase b, and lowercase c, and they are the sides that are opposite of their designated angles. So if I am looking for sine, first of all I'm going to write it as S-I-N of whatever angle I'm looking for, angle A. And if I'm looking for cosine, it's going to be C-O-S of angle A. And then finally tangent would be T-A-N of angle A, or whatever angle we're looking for. We just put the angles in there. Okay, now how do we actually find these? Well, the way we actually find them is we use a relationship between the sides. Okay, so we have to understand what opposite is and adjacent is. Adjacent is a side that's touching. And then opposite is going to be the side that's not touching, the side that's furthest away from it. Okay, so let's figure out what the sine, cosine, and tangent of angle A is. So if we're looking at angle A, the sine of angle A is always going to be the opposite over the hypotenuse. And remember, the hypotenuse is always the longest side. Alright, then the next one, we have cosine. Cosine of angle A is going to be the adjacent side that is not the hypotenuse. So it's going to be B over the hypotenuse. And then finally, the last one is going to be tangent. Tangent is kind of unique because it is going to be the opposite side over the adjacent side. Okay, so that's how we're going to use the right triangle and use the different side lengths to find what we need to find. A way that you might want to think about to remember all of these things is there's a little saying, SOHCAHTOA, S-O-H, sine equals opposite over hypotenuse. C-A-H, cosine equals adjacent over hypotenuse. TOA, tangent equals opposite over adjacent. So if you can remember this, it will help you to remember how to match things up. Now we're going to do some examples finding sine, cosine, and tangent of angle A. So first we're going to find sine of angle A. So sine of angle A is going to be opposite, which is 15, over my hypotenuse, which is 17. So my answer is 15 over 17. Next, we have cosine of A, which is going to be equal to my adjacent side over my hypotenuse. So that's going to be side touching, 8, over my hypotenuse, which is 17. And finally, tangent of A is equal to opposite over adjacent. So that's going to be my opposite side, which is 15, over my adjacent side, which is 8. So 15 over 8. And those are your basic trigonometric functions of this triangle. We can also find trig ratios on a calculator. Now, the key thing you have to be sure of before you start typing things into the calculator is that you are in degree mode. Okay, if you're not in degree mode on the calculator, it's going to give you a really weird answer. Okay, so double check to make sure your calculator is in degree mode, and then you should be able to type it into the calculator. So what you're going to do is you're just going to type in the cosine button, so we're going to type cosine, and then you're going to just type in 55, and then you hit enter. Okay, so if we were to do that with cosine of 55 degrees, you would get 0.5736. You just round it to about 4 decimal places, and then you can see how it behaves. So it's going to be a decimal number. If it's not a decimal number, you might have made a mistake somewhere. Okay, the next one, sine of 80 degrees. So this time, we're going to type the sine button, and then you're going to hit 80, and then enter. So we would get about 0.9848, and that would be your final answer. And the last one, we have tangent, so we're going to hit the tangent button of 45, and then hit enter. So that's going to give me 1. So that's your final answer, just 1. Alright, so when you're doing these, you just have to make sure you're careful about which sign you're using, and make sure that you are in degree mode on your calculator. For these next examples, we want to find the missing side. So I want to find the side of x here. So I need to figure out which trig function I need to use. Remember, I have SO, CA, TOA. Okay, so if I'm looking for the side x, I know my angle 48. So that would be opposite and my hypotenuse. I know those things. So I'm going to be using sine because it uses opposite and hypotenuse. Okay, so that means setting it up, I have sine of my angle, which is 48 degrees, is equal to my opposite over my hypotenuse. So sine of 48 degrees is equal to x over 14. And now I just have to solve. So I'm going to multiply both sides by 14 to cancel out the 14. So I have 14 times sine of 48 equals my x. So that's what I type into my calculator. 14 times sine of 48, which is about 0.7431, equals x. So I'm going to type that, and I get x is approximately equal to 10.4034, and that would be your final answer. We're going to do the same thing on this next example. we need to decide. So, katoa, which one are we going to use? So we're looking for the hypotenuse side, the long side. So we have to use either sine or cosine because the hypotenuse has to be involved. Now we have our angle measure, and the side length that we have is touching it. It's the side adjacent. So I'm actually going to use cosine because I have enough information for that one. Okay, so I have the adjacent side of an angle and I have the hypotenuse of an angle. So cosine of my angle measure, which is 35 degrees, is equal to my adjacent side over my hypotenuse. Okay, so cosine of 35 is equal to my adjacent side, which is 1.575 over my hypotenuse, which is x. So on this one, what I'm going to do is I'm going to multiply by x first so that I can get rid of the denominator. So now I have x times the cosine of 35 degrees equals 1.575. Now, I type cosine of 35 into the calculator and I get roughly 0.8192 times my x equals 1.575. So now I have to solve for x. So I'm going to divide by 0.8192. And I would get x is approximately equal to 1.9226, and that would be rounded off. So that would be your final answer. It's not exact, but it's pretty close. So you're just using your algebraic operations once you find what your cosine of 35 is. And that's your final answer. For this last example, we want to actually find angles instead of finding the actual side lengths. So this is a little bit different. We have to use a slightly different technique to do. We're going to have to use what's called the inverse cosines, and inverse sines. Now to do that, all you have to do is hit the second key, and then you can go up and do the inverse, the opposite of the actual trig function. So the first thing I'm going to do is find x. So x is one of my angles, so I'm going to use opposite and hypotenuse. So I'm going to use sine of x, and I'm going to get opposite over hypotenuse, which would be 12 over 24. Now if I want more exact answer, I have the sine of x equals 12 divided by 24, and I would get about 0.5. So now I need to get rid of the sine part. So I'm going to take an inverse sine of both sides, and that's going to cancel that part out. So I'm left with x equals the inverse sine of 0.5, which I can just type into the calculator and get x equals 30. So that would be your final answer. Now the last one is the y. So for y, we're going to use the side adjacent and the hypotenuse. So that is cosine. So cosine of y is equal to adjacent over hypotenuse, which is equal to 12 over 24. Okay, which that is obviously equal to 0.5. So I have the cosine of y is equal to 0.5. Okay, so now the next part is to get rid of the cosine part. So instead of doing an inverse sine this time, I'm going to do an inverse cosine of the 0.5, canceling out the cosine parts there, leaving me with y equals the inverse cosine of 0.5, which you can type into the calculator, and you would get y equals 60 degrees. So that would be your final answer, 60 degrees. Okay, and another way you can check that is the angle measures all add up to be 180. So x plus y plus 90 degrees, which is this little box here is 90 degrees, has to equal 180 degrees. So if you have x, then you can find y, because we knew that x was 30, and we didn't know y, but we knew that 90 is the box, so we just needed to find y here, because we know it equals 180. So you can do it that way too, and subtract over, whichever way works best for you. So those are your notes over trigonometric ratios. Go through some practice problems, make sure that you understand the different ways to use these trig functions, and then you can do your quiz over this material.